Hello, everyone, and happy St. Patrick's Day. Today, I'm going to take a look at the notes from section 5.3, graphs of other trigonometric functions. I'm going to make a few different videos, one page at a time. And now I'm going to bring up the lecture guides from section 5.3. Give me just a second. Okay. So as you can see, we're on page 4 of the lecture guide. And I believe we actually started this a little bit last week. So remember that in general, the period for tangent and cotangent graphs in general is pi, and if we're doing tangent of b times x or cotangent of b times x, the period will be pi divided by b. So for our particular function here, f of x equals 2 times the tangent of x over 4, b is equal to 1/2. And so the period is equal to pi divided by 1/2, which is 2 pi. Next, we want to find two neighboring vertical asymptotes. So in general, for tangent, we will do b times x is equal to negative pi over 2, and b times x is equal to pi over 2. So for this particular function, we'll do b times x, that's 1/2, times x equals negative pi over 2. And this gives us x equals negative pi. And then we will also do 1/2 x equals positive pi over 2, and that gives us x equals pi. Now we know where the two asymptotes will be. Next, we're going to find an asymptote, not an asymptote, an x-intercept between the vertical asymptotes. The tangent will always set b times x equal to 0. We'll have 1/2 times x equals 0, and that gives x equals 0 and the x-intercept. Next up, we'll make a small table of values, and I'll do that right over here to the side. So first I'll have a column of x's, and then I'll have a column for the y values. And remember, y is 2 times the tangent of x divided by 2. And if x is equal to negative pi, if we plug in negative pi, we're going to get 2 times the tangent of negative pi over 2, and this will be undefined. Okay? Remember, there was an asymptote at x equals negative pi, so that makes sense that it would be undefined. Next, we'll take a look at negative pi over 2. If we plug in negative pi over 2, we have the tangent of negative pi over 2, and we will divide that by 2, and so we get 2 times the tangent of negative pi over 4. And that's going to be 2 times negative 1. That gives me negative 2. plug in 0, I have 2 times the tangent of 0 divided by 2. And that'll be 2 times the tangent of 0. That'll just be 0. If I plug in pi over 2, I get 2 times the tangent of pi over 2 divided by 2. So in other words, 2 times the tangent of pi over 4. That gives me 2 times 1, and that's positive 2. So let's go ahead and now plot these points. My graphs aren't going to look as nice as they do in class. When x was equal to 0, y is equal to 0. So I'll go ahead and put a little point right there. When x was equal to negative pi over 2, I got negative 2. So I'm going to go ahead and label my x-axis. Here's negative 1 and negative 2. I'm sorry, this is my y-axis I'm labeling. Then I'll go ahead and put a point here where x is negative pi over 2 and y is negative 2. I'm going to label my positive y-axis. And when x was pi over 2, I got that y was equal to 2, so I'll go ahead and put a point there. Remember the asymptotes that we came up with where x equals negative pi and x equals positive pi. So I'll go ahead and graph my asymptotes. And I'm going to do the best I can of drawing a nice smooth curve like so, and then a nice smooth curve on this side. And I can go ahead and repeat this. So remember, this is one period of the graph, and so it has a period, remember, of 2 pi. And what that means is, since the period is 2 pi, that means that f of x plus 2 pi is equal to f of x. And so that tells me that f, and what I'm going to do is I'm going to say x equals 0. So f of 0 plus 2 pi will equal f of 0. So that means that f of 2 pi equals f of 0. And since f of 0 was 0, that means f of 2 pi will also equal 0. So I can go ahead and plot a point here. And then I know that I'm also going to have a point right here. Basically, every point will appear again when you move over a distance horizontally of 2 pi. And then so I get this part of my curve here. Also, this point at 0, 0, we knew we could move horizontally 2 pi to get another duplication of that point. We can move a distance of negative 2 pi. And then this point right here will repeat itself a distance of 2 pi to the left. And so I can go ahead and connect these points with a smooth curve. Okay. So up above, we mentioned some things about the neighboring vertical asymptotes for tangent and the x-intercept in between those vertical asymptotes for tangents. Now I'm going to do the same thing down here for cotangent. So for y equals a times the cotangent of b times x, the asymptotes, the vertical asymptotes, are at b times x equals 0 and b times x equals pi. And the x-intercept between the vertical asymptotes is at b times x pi divided by 2. So now we've finished up page 4. I'm going to see if I can figure out how to stop sharing. I don't remember how to stop sharing, so I'm just going to stop recording. And the next video will be page 5.